Right, so now we're going on to section 7.2, which is verifying trigonometric identities. And so really it's a lot of like just a section that we did in 6.1, which we used our trig identities. And we're going to talk about some of those really useful trig identities. But we're going to use it to verify other identities. And then we're also going to use it a little bit to find the numerical values of trig functions. So we're going to start with some hints for verifying. So we're going to have two sides. So you're going to be said, this side of the equation, you need to prove it. It's kind of like a proof that we did in geometry. We're proving that it equals the other side. So some hints. So you start with the more complicated side, and then you work to make it look like the only other side. You only want to work on, change, modify one side at a time. There are times I'll have students say, well, I kind of changed them both. I worked on both the right and the left side, and I just want them equal at some point. Yeah, it kind of works, but it's really not really how we do a proof. And so we only want you to look on one side to get it to look for the other. Have your trig identities handy. That's your blue sheet that I handed out. Have that blue sheet handy. It's on the trig identity formulas kind of thing is on the Moodle website as well. Multiply by 1 over and over again. We're going to think, how could I multiply by 1? It's really not a trick. It's a mathematical, possibility that's okay. You don't change the value when you multiply by 1, but it's never just a 1. It's always the same value over itself. It's a sine over a sine or cosine over cosine, any number over itself. We always start by putting everything in terms of sine and cosine, and this is really helpful. So some useful identities. If we see cosecant, we're going to call it 1 over sine. If we see secant, we're going to call it 1 over cosine. If we see tangent, we're going to call it sine over cosine. If we see cotangent, we're going to call it cosine over sine. And the last one that's really helpful is sine squared plus cosine squared equals 1. We're going to use these so much, you hopefully just memorize them. This one, excuse me, we manipulate a lot. We don't just see it as sine squared plus cosine squared. We talked about this in the other video. We sometimes will switch it back and forth. We'll call 1 cosine squared might be equal to 1 minus sine squared. We might say sine squared minus 1 equals negative cosine squared. So we're going to see some of that here too. So we have an example here. All right, we're going to verify this identity. So verify means prove one side equals the other. So we're going to start with the left side of our equation, and we're going to try to get it to equal our right side. I had the choice of saying, okay, here we have secant squared minus tangent times cotangent equals tangent squared. So I had the choice of saying I'm going to mess with the right side, make it look like the left side, or the left side, make it look like the right side. I'm going to choose my more complicated side to kind of make it look like my more basic side. So I really want to look at this and see if I can simplify this part to make it look like tangent. So my first suggestion, put everything in terms of sine and cosine. So secant squared is 1 over cosine squared. Tangent is sine over cosine. Cotangent is cosine over sine. And then we ignore this right now. In fact, we're trying to make this side look like this. All right, what can we reduce? I can reduce down my cosines, and that's it. So let's see what I have. I have 1 over cosine squared, and then minus sine. Oh, I missed one. I could reduce this. 1 minus 1. Now, 1 over cosine squared equals, I go back to secant squared. So really I have secant squared minus 1. Secant squared minus 1, if you remember from one of our identities that you were given on your blue sheet, you should be able to see your blue sheet, one of your identities was tangent squared plus 1 equals secant squared. Well, if you subtracted 1 from both sides, doesn't secant squared minus 1 equal tangent squared? It does. Therefore, and actually I should have kind of had this over here, shouldn't I? I'm kind of off to the side here. All right, therefore, I have proven it. All right. A lot of times what we'll do, you'll see me do is like that. That says, okay, I proved it. I proved that my left side could equal my right side. That's what my goal was, all right? So what I had over here was always just my goal. That's what I wanted to look like. That's kind of my hint of, oh, I'm done. I don't need to simplify any further. Let's look at another example here. Okay, again, I do have a complicated side and a non-complicated side. So I'm going to be messing with this side. Sine over cosecant, excuse me, cosecant, there we go, plus cosine over secant. And I want it in the end to look like this. So this is going to be my goal side. Notice how I'm kind of getting rid of all my A's in there. It doesn't matter till the end. So I have a goal. This one's going to be my goal over here. I'm going to mess with this side. It's kind of a, doesn't matter really what side. So I'm going to say sine and cosine. Sine I'm going to write like this. Cosecant, really what I'm doing here is sine divided by cosecant. So it's sine divided by 1 over sine. We'll talk about that in a minute. And then cosine here, and I'm dividing it by 1 over cosine. So dividing here is I can multiply by the reciprocal. So sine times sine over 1. And then this is cosine times cosine over 1. So really what I have here is sine squared plus cosine squared, which is 1. Sine squared plus cosine squared is 1. Well, how does that equal cosecant plus 1? Well, sine squared plus cosine squared equals 1 can equal a lot of different things, okay? One of the things that you might have remembered on your list over there was 1 plus cotangent squared equaled cosecant squared. If I subtracted cotangent from both sides, 1 would equal cosecant squared minus cotangent squared. All right, so technically this does equal cosecant squared minus cotangent squared. And I am done. Okay, let's look at another one. So another example. Cotangent. Now this is just like what we had yesterday. In fact, I think we had this one yesterday. So there's times where you're going to be asked to just simplify and you're not going to be given given a goal like we were with the other one. So there's simplify versus verify, and I just kind of wanted to show you the difference. Simplify does not show you the goal. This is what we're working toward. Verify, you have the goal, and you can make your goal either side. I could have made my goal either side here, and then I know what I'm working toward. Where if I said simplify and I just showed you here, this side, I would have stopped here at 1. But the fact that I had a goal I had to get to meant move on to that next step. So we're going to leave cotangent over tangent is just going to be equal to 1. So that one's an easy one to simplify. Let's look at this one here. Let's look at cotangent times sine, and I'm going to do it like this, divided by cosecant times cosine. So I divided it that way. Okay, cotangent I'm writing as cosine over sine, times sine I'm writing as sine over 1. I'm dividing it by 1 over sine, and I'm multiplying it by cosine here. Well, here, my signs go away. So what I have before I can divide here is I'm going to need to flip this fraction. So in order to multiply this, it would be the sine would be the numerator, and the cosine would be my denominator. And this one has, my cosine is my numerator, and 1 is my denominator. Now I can reduce even further, and my answer here becomes sine. All right, from today's assignment. Now this is on the worksheet today. Now I'm looking at number 7. I'm thinking, well, definitely the easier side, the basic side is this side, the cosecant squared. So I'm going to make that my goal, okay? So I'm going to say, okay, this is going to be my goal, which means I need to manipulate this side. So I'm going to write cotangent is cosine squared over sine squared. I'm going to write sine as sine over 1, and cosecant is 1 over sine. Look at this. What happens to my sines here? My sines go away, and I'm going to say that equals, there's not a lot of space here, that equals cosine squared over sine squared. I'm going to go back to cotangent squared. I don't think it helped me that much, plus 1. Now, if you remember, cotangent squared plus 1 is actually equal to cosecant squared, and that is on your blue sheet. All right, so having those identities on your blue sheet really is helpful. For number 9, now in number 9, I think I'm going to make this my goal. I'm going to make that my goal here is to get to tangent sine. All right, so I'm going to start on the other side. I'm going to start with secant. Secant I'm going to write as 1 over cosine minus, I'm going to write this as cosine over 1. Well, I need to have common denominators in order to subtract these two. So I'm going to make, and I'm going to multiply, remember that power of multiplying by 1? I'm going to multiply by cosine over cosine. So now I have 1 over cosine minus cosine squared over cosine. Okay, so now I have 1 minus cosine in my squared, in my numerator, and cosine in my denominator. Well, 1 minus cosine squared is actually equal to sine squared. So now I have sine squared, I'm going to write it as sine times sine over cosine. Well, this part of it right here, sine over cosine, is really tangent. So I can write that as tangent. I'm going to write it down here. I need to extend even a little bit further, excuse me. I'm going to write that as a tangent, and then it's times sine. And all the time, you kind of work down is what we do here. You know, the idea is that we're working down. But that was my goal. That's what I was trying to work toward here, is to get tangent sine. That's, remember, my goal up here, tangent sine. And so I was able to kind of achieve that goal. All right. So I'm going to go ahead and stop this, and we'll have more practice at another day. Well, you know what? I do have a few more minutes. Let me go ahead and solve this one. Obvious to me that I'm going to have secant as my goal. Okay. So I'm going to write tangent as sine over cosine. All right. This is an interesting one. How do I get rid of this 1 minus sine in my denominator? Well, there's a little trick here, and I think that's probably why I must have chose that you did this. Okay, we're going to look at 14 now. 14 is a tough one. It really is. Because there's kind of a trick in here. There's a trick when you have like that 1 minus plus sine theta on how to get rid of it. So we have here tangent, and I can write it here as sine over cosine. All right, let me do that. Sorry, guys. So we're at sine over cosine. And then we're adding it to cosine over 1 plus sine. The trick on getting rid of a 1 plus sine is we're actually going to multiply this. And I kind of have to show you the trick to see, and it's not really a trick, it's a mathematical trick, which is a very, so I'm multiplying by 1 there. And I said, okay, a lot of times we multiply by 1. The beauty in multiplying this one by 1 is my new denominator becomes 1 minus sine squared. All right, because the 1 times the 1 is 1. Inside and outside is a positive sign and a negative sign, which becomes 0. And then the last would be sine squared. So on the top, it would be cosine minus cosine sine. Okay, so we have 1 minus sine squared on the bottom. Well, 1 minus sine squared right here, and this is still sine over cosine. All right, 1 minus sine squared is really cosine squared. So really we have cosine minus cosine sine all over cosine squared. Well, another trick is that you can kind of split this up. You can make it cosine over cosine squared and then minus cosine sine over cosine squared. Okay? And if you can imagine this cosine squared, this is really 2 cosines, it gets rid of one of them. This cosine squared, this is really 2 cosines, it gets rid of one of them. And if you imagine, we still have this here. Oh gosh, you run out of space. So now I have sine over cosine plus 1 over cosine minus sine over cosine. Well, sine over cosine, this little part of it right here, look at this, right in there, that little part of it is a 0. So really, it becomes down to 1 over cosine. What does 1 over cosine equal? But secant. What was our goal to begin with? But to get secant. So in the end, we got our goal. We got it equal to secant. It took a little bit of time and a little bit of effort, but we were able to master it. Good luck.